Welcome to my Mastering VMware's vSphere 6. Here we're doing Chapter 8, Securing VMware vSphere 6. So it's actually really interesting because the name of this chapter should be Securing VMware vSphere, but also securing our VMs. Big part of that is things like patch management and authentication, authorization, things of that nature. So first thing we have to talk about is our standard AAA model. AAA is authentication, authorization, and accounting. Basically, the accounting is so that all actions can be tracked and logged for future reference. But the big thing here is that whole accounting needs to be able to account for specific users, meaning everyone should have a unique identifier. No general account. Everyone has a specific user that they can log into. Authentication basically provides verification that you are who you say you are. Authorization is basically you're allowed to permit whatever tasks that you're trying to do. For example, you go to an ATM. Your debit card is a way to authenticate you. Your PIN number is also a way to authenticate you. That's dual factor, that's two-factor. Something you have, your ATM card, something you know, your PIN number. And then once you actually insert the card and they verify that you are who you say you are, they've authenticated you, what are you capable of doing? What are you authorized to do? Most banks, you're authorized to withdraw up to $300 or $500, depending on your bank. But if you want to limit what you can do with that card, you can. For example, I have a business debit card where I only am allowed to make deposits. So even though I have been authenticated with that card, my authorization level is just deposits only. And then again, all of this goes back to logging and accountability, so that last one has to be there. It's not just part of this, it's all three of them. They tie together. Basically, can we track it back down to who did what, and can we make that where it is irrefutable? So if we're talking about configuring controls for authentication, there are mechanisms in vCENTER that we use to manage ESXi hosts that rely on ESXi authentication. Basically, we can have permission set through vCENTER so that we can do this. So there are instances when a task cannot be accomplished through vCENTER server. Basically, if you're trying to perform a feature or a task that requires authentication and vCENTER is down, then you can't perform those tasks because they rely on that vCENTER for specific types of authentication. Or if you're trying to troubleshoot some type of ESXi boot, where it's the ESXi host itself is not even fully booting, and that's even way before vCENTER. So we can do things such as managing user locally, meaning we can have specific users local to each ESXi host. So there's different ways for us to do that. We can do it through a vSphere client connecting directly to an individual ESXi, or we could do that via command line. Both are cumbersome, but can happen. Creating and modifying groups is not supported for ESXi hosts. Creating and modifying users are. My favorite is ESXi has an integration tool for Active Directory. So if you already have an Active Directory infrastructure, guess what? Your ESXi hosts probably should be connecting to it. That does mean things such as your ESXi hosts need to be able to resolve domain names. You have to make sure to set up the appropriate DNS. And we have the appropriate group for management. Here they say you have to create an ESXi admin group. No, you don't. You have to create a group in Active Directory that will be managing ESXi, but it doesn't have to be called ESXi admin. It can be called whatever you want. So again, we can have local access. That's going to be physical access to the server. That could be a direct console or a local shell. We could have network access. That could be a remote shell or a vSphere, either desktop or web-based client. Basically, how are we connecting to our ESXi environment? Are we physically in front of the server with a monitor and keyboard plugged into it? That's local access. That's direct console access. Are we talking a remote shell through the network? Are we talking about the web interface? Those are the network access levels. ESXi does have a firewall. What gets really funny is this screenshot. I know it says ESXi 6. This is not the web interface. This is actually the desktop client. So there is still a firewall in here, and you can block or disable certain ports based off of your requirements. So both vCenter and ESXi hosts use the same structure security models to allow users to manage portions of that virtual interface. Infrastructure. This model consists of very general users, groups, roles, and permissions, just like anything else. But you can centrally manage them vCenter, or you can manage them per host through ESXi. The two major groups, users and groups, this is what we're going to be authenticating. This is going to be an authentication mechanism. These are going to be the accounts that will be used. Users and groups form a basic building block for that security model. So normally we assign users to groups and we assign groups to objects. Who can log into ESXi? Well, we will assign a group to that, and we will assign the appropriate users to that group. So that's the authentication. Next is authorization. Well, what can they do? Those are going to be our privileges, our roles, and our permissions. So a privilege is the action that you can perform on an inventory-based object. In vSphere, everything is an inventory object. Roles are a collection of privileges. And you can do roles both in vCenter and in ESXi, because there are built-in roles that are created. Next, permissions. A permission will allow specific users to perform activities specified by the role assignment. So there are some slight differences. Big thing is permissions. You can assign one-to-one. Roles are, again, a collection of privileges. So what's the difference between privileges and permission? Both are the activities that you can do, but permissions are a little bit more finite. They're a little bit more specific. All right, going on to the next part, part 2. We're going to talk about how to secure vCenter. So you have to first of all understand how to secure vCenter, how to secure the underlying operating systems, how to make sure that we're doing the appropriate patches, and we're not using the default general SSL certificate. You'll notice in our lab environment, we're still using the default self-signed SSL certificate. That's because in our lab environment, we don't really need to generate a real certificate. However, normally you would be. The SSL certificate does matter in a real environment, but for our lab environment, just being able to skip through it, it's more than sufficient because, again, typically a valid SSL certificate, unless you're setting up your own PKI or certificate authority infrastructure, you're probably going to be purchasing one. So, with that said, for our lab environment, the default self-signed one is perfect, but for a real environment, you want to get a self-signed, or not, you don't want to use a self-signed, you actually want to get a certificate authority issued one. So management of the certificate is typically an erroneous task for administrators because it's mundane, it's boring, but it's something that's super important because, again, it helps secure your environment. Each component in the vSphere architecture does need a specific and valid certificate. So a wildcard is always really good here. VMware endpoint certificate stores called vSecs and the VMware Certificate Authority, VMCA, helps with this process. because this helps kind of manage all of your certificates. They also provide a certificate manager, and this is a tool that's integrated with both the VCA and the VECS. So when you're trying to replace certificates, they give you this nice, lovely tool, which I don't think we've actually done a lab for, but this is something that in a real environment does become very handy. Fun part is, whether you're using the Windows-based or the Linux-based or the virtual appliance, all of them have the same authentication mechanism. And generally, you'll probably be authenticating against Active Directory or a common type of directory service, such as like OpenLDAP. But all of the features with VMware's vSphere 6 actually do play very well with any type of directories type service. So steps to issue an authenticated session with SSO. Basically, web browser will connect using the web client. The username and password is issued to the SSO server. A token should be generated. The SSO server sends a request to the relevant authentication server, whether it's going to be a local mechanism or Active Directory or other type of OpenLDAP type system. Once the authentication is successful, SSO will pass a token back to the vSphere web client, and this token will be used on how to authenticate directly with vCenter. So it seems like a very cumbersome process, but honestly it really isn't. And in our lab, we'll be showing how to set up the authentication process, so our web client will be able to sign in directly using our current sign-on credentials. Very simple, very easy. So let's talk about some of the built-in accounts. We have what's called a VPX user account, and in vSphere, everything that we've been doing so far has been using this account. And the problem is, every time we log into vSphere, we're using the same account, but if we have multiple users logging into vSphere, we all have the same account. And you can't really account for that. You can't really track that. So the accountability function isn't really working very well here if we're always logging in with that VPX user account. It's generated when we create vSphere, and it already has the administrator role. We can manipulate that based off our requirements, which we're going to be doing that in the lab. So again, when we're logging onto vCenter, we're not really logging onto the ESXi's directly. We're logging into a centralized platform, and that platform will pull the appropriate ESXi hosts or the administrator accounts so that they can be communicating directly with those ESXi hosts. When we do that process, so when we connect to vCenter, vCenter connects with the hosts using that VPX user account. So that's why in our lab environment, on our vCenter machine, if you used a local account to install vCenter, that account can actually log into vCenter, but vCenter has nothing in it. Because again, that was an account that was created so we could log into vCenter with it. But if you're logging in with vCenter with the appropriate default administrator account, you actually see the things like inventory. That's because the local account on vCenter does not have permission to use VPX user. However, the built-in administrator account does. So in our lab environment, when we're actually adding our vCenter and ESXi host to Active Directory, you'll slowly start seeing that our newly created user accounts in Active Directory can start logging in and can start seeing the inventory. Here are some of the built-in vCenter roles, things like administrator, read-only, no access, and then the appropriate tagged roles just in case. Because again, you may have a user that needs to be able to do database administration or network administration, but you don't want to give them full access to everything. So you can actually, based off of the roles that they are needed, you can provide the appropriate access. So how do we secure the VMs? So the key feature here for our VMs is understanding a good network security policy and how we can set that in our vSphere virtual networking environment. So for example, things like MAC address changing, or forge transmissions, or promiscuous mode. These are all really good security features that are built into vCenter, but again, it kind of depends on what you're doing. Like if I'm doing a IDS or IPS, understanding how to make the appropriate ports go into promiscuous mode, kind of important. That way, I can control traffic and still monitor. Last slide we have to talk about is actually about patch management. Whether we're talking about ESXi, whether we're talking about vCenter, whether we're talking about VMs, everything in our infrastructure needs to be kept up to date. How we do that is going to be dependent on the administrators that are going to be administering that. If we're using VMware's Update Manager, it can do that. If we're working on just manually updating them, we could do that too. But the big thing here is everything needs to be kept up to date, period. If we're using Windows servers or Windows products, we could be doing all of the update management through a System Center, SCCM, or there's other features out there that can do that as well. Again, the important part here is all operating systems, all of our infrastructure needs to be kept up and current with updates. That's the end of this chapter. I want to thank you.